All right, time for another draft. Physics.com, debatephysics.com also, but can't acquire debate in any kind of nice and back and forthy kind of way. You make an argument, they make an argument, blah blah blah. Just can't do that on the internet for some reason. So anyway, this guy, Folse Nuclear, what was that for? Toby? No, I forgot his name. All right, shoot me. You know what happens. Anyway, I had emailed him and I got no reply, requesting that, maybe you ought to pay attention to this kinetic energy versus momentum subject, kind of important stuff. Blah, 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 nothing. So he does these reply videos to other people's videos, so it seems totally appropriate that somebody should reply to his crap videos. But he's not very critical. He thinks Veritasium knows what the fuck he's talking about, which, frankly, it's just such extraordinarily wooey bullshit that, it's hurts the brain. He apparently never watched the PBS guy. He only did one video response to him. And, that is all such woo physics. And it's just, but whatever. So he's in the very industry, the energy industry, okay, and he doesn't see a problem, kinetic energy versus momentum. Somehow it's compatible. Somehow it's always good. Yeah, you can always conserve both. They haven't done any thinking at all. So I probably only get through maybe 3 minutes of this video because, there's going to be such egregious trespasses against logic and reasoning, that I will have to interject. Anyway, so we'll do part of his introduction anyway.
It's time for more Veritasium. Specific.
It's Veritasium. I mean, that's how Veritasium says Veritasium is Veritasium. He doesn't say Veritasium. But anyway, potato, tomato.
The biggest misconception in physics.
Right, a total clickbait piece of shit video where, he puts this stupid thing on here of like an asteroid or something and says energy is not conserved. Bullshit in all kinds of ways. It's bullshit in the sense that we all know energy is conserved even when something stops moving. So even when we know, like, a ball rolls across the ground. We know the energy was conserved in the sense that now something else has the motion. We know the bowling ball's energy is conserved. Yes, the ball stops moving, but the pins are moving all over the fucking place. So we know the energy is conserved. And so it's just more games being played because you transferred the energy, therefore you didn't conserve the energy, which is bullshit. But yes, their underlying argument is somehow that energy really isn't conserved, which is really stupid. And this guy falls for it. An energy expert falls for nonsense.
Energy is not conserved, though it's pretty.
I don't know what the jump cuts are about either. So he has to do all this editing because he can't even get through the introduction, with consistent sentences. Sorry, but I mean, just such bullshit.
Close if you're talking locally. For those of you who don't know me, I'm Tyler Folse.
Okay, enough of that. So he's a nuclear engineer, blah, 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 blah. I'll be back when he's done. So, back. So, yes, he's a nuclear engineer with 10 years experience, which isn't that much. And it's, we don't, he's kind of, well, I've swept the floor and, I did the other things too. Emergency response isn't really anything to do with nuclear engineering, but anyway, whatever. So now he's playing the video clip where Veritasium is starting his argument, and he's going to propose that there's an astronaut in space and no gravitational field, and he's going to throw a rock, and he's arguing that somehow the rock won't keep moving. And the truth is, it won't keep moving forever. We've all been duped by physics that says this kind of stuff without even telling you the obvious, which is, well, space isn't like no air, it's like very little air. Okay, there's no perfect vacuums. And so the fact is that if you give it a billion years, maybe it will stop moving because If I take 1 billion years worth of space and compress it and just consolidate it into a material object, all of the matter in that billions of years of distance, the fact is it's substantially a real substantial amount of matter that it's going to hit in its travel. And with each impact, just like in regular atmosphere, with each impact with the atmosphere, you're transferring your energy. That's how you lose the energy. You don't just lose energy. Energy isn't destroyed, it's transferred. I have to explain to a nuclear engineer that energy is only transferred. Oh, so irritating.
Imagine you're an astronaut out drifting in deep space. When you throw a rock as hard as you can.
Why does it matter how hard I throw it? Okay, and the point that's just so glaring here is, let's talk about this. If I throw a little rock faster, it'll have more kinetic energy. So somehow I gave it more energy. The smaller the object is I throw, the more likely it is to have more kinetic energy. That is, unless you think it's impossible to throw something half the mass twice as fast, and you think you could only throw it 1.4. The fact is, the lighter the object I throw, the more energy I'm producing some magically way. So make it lighter and faster and have the same momentum, but I made more energy. But it won't happen to the guy who threw it. The guy who threw it's only going to get the momentum of that rock. So it doesn't matter how big it is or how small it is. It just matters on what's the momentum he gave the rock, because that's the only thing that's going to move the astronaut. And instead of dealing with that fundamental, elemental subject, they just talk all this wooey bullshit about fucking nonsense.
What's going to happen to that rock? Well, you would think.
So you have, yes, in the visual, the sense of there's some wooey, there's some stuff in that space. It's not perfectly black, right? They put stuff in it, like it is moving through something. And we know that the universe is clumpy. So we know there's places where there's gas and there's all kinds of atoms floating about, and we know it distorts light and it does shit. So we already know there's places where there is an atmosphere, so to speak. We know the sun is producing a ton of particles. They reach all the way to the earth. A ton of, high energy, fast moving electrons, protons, neutrons, bullshit that the sun creates. And that if it wasn't for the fact that, we have a magnosphere, life wouldn't even be possible, because it's enough energy to just annihilate everything. It's radioactive. Essentially, the space is actually radioactive, and it's full of matter moving, not just force, matter moving, not just gamma rays. Actual material pieces of shit are flying off of the sun. So obviously, you could argue that over time, anything orbiting the Earth is going to slow down and crash into the Earth, and anything flying through our solar system would be hitting stuff and transferring its momentum. Every time it had an impact, the heavy thing hits little tiny pieces, it's going to make the little pieces bounce off with a piece of its energy. Whatever has the most momentum wins and transfers its energy. Wins in the sense of it's going to influence the other thing. So if I throw a rubber ball at a moving car, the rubber ball comes back with some of the car's energy. The car doesn't get any energy from the ball. It just gives energy to the ball. It loses energy. That's what happens. And that's what's going to happen to that fucking rock. It's going to lose energy over traveling millions of miles, not just billions. Okay? So they're theorizing that in a trillion zillion years, by Einstein's theory, somehow enough fake space will be created everywhere in the universe to tire the rock down. So somehow the rock is going to lose its frequency, like a photon or something. Its frequency is going to stretch into this preposterous length where it'll lose all of its energy because it lost its fake frequency. I mean, it's just such a silly pile of shit, when the obvious truth is it will in fact stop. Because guess what? It's going to be transferring its energy to little tiny hydrogen atoms and other little particulates in the space. There are little shitty, tiny micro meteorites It's going to transfer its energy to those objects and eventually be out of energy. Truth. But that's the rational argument. They completely evade the rational argument and are making this wooey, silly argument instead. So it's an interesting piece of information about how you've propagandized your whole fucking life about how, oh yeah, you throw a wrench in space and just keeps going forever. Well, that was dumbass physics. That wasn't physics for smart people. Okay, that was just fool you, you idiot physics. We were all fooled by that crap. Because we should have been able to figure out, well, no, that's not true because empty space isn't fucking empty. I already know it's not empty. I know there's gamma rays, there's cosmic rays, which are, helium nucleuses that are smashing into everything. There's all kinds of shit in the universe besides just force. There's all kinds of material shit with motion, and that stuff can transfer energy. You hit something with matter, it can transfer the energy. And it will, if it has more momentum. Guaranteed.
Think that it would continue with constant velocity in a straight line. That's just Newton's first law.
So it's not true, though, okay? Yes, it's Newton's first law in principle and Newton's idealization, and it was an idealization. There's no idealization here. You just drew the picture. This wasn't an idealization. You didn't say in a completely evacuated universe of pure nothing. No. So it's just bullshit.
I like that all these physics thought experiments start off with you in deep space. It's good, you don't have to worry.
Okay, so jump cut. So he likes they start off in deep space. I wonder what what he really said. The trick is there any such thing as neutral deep space? Is there any such thing as I'm in a perfectly neutral gravitational field? No, there's never such a thing. Just like there's no such thing as a perfectly neutral charge field for an electron. I stick an electron anywhere in the universe, any place I stick one, it's inevitably going to be closer to some object it can get closer to. That is, the closer it gets to it, the stronger the force gets. So it's always going to go in some direction. It's never just going to stay there.
Worry about things like localized gravitational fields, except your own, but it's negligible.
So again, your own negligible. No, there's all kinds. It's not negligible. I mean, you can actually see that with these meteors. So he drew the rock like a meteor. And the fact is there's meteors, and they have this shape to them. And it's as if they didn't smack into each other. They merged into each other. That they're made out of some, unhardened cement. Like especially comets. And they just molded to each other. You can extract them and leave the dent behind.
But what actually happens is it eventually slows down and stops.
Takes a while.
Right, so it takes a lot less time if you add up how much atomic material it's hitting. So if you figure out how much atomic material it's hitting per million miles or whatever, that number will stop it way before Einstein's. Well, it's not even Einstein's, right? This isn't really Einstein's theory, okay, of expanding space. I mean, Einstein never proposed that space was poofing and getting more and more space was being put in the universe. So that's their wacky interpretation. So they're going to say it's Einstein, but it's not Einstein's fault. Einstein didn't say rocks stop. At least for that reason. He didn't say they stop because they lose their frequency. Yeah, he didn't say that. Einstein didn't think a rock had a frequency.
So why does this happen? Where did all the rock's energy go? At the turn of the...
Well, you mentioned straight line. I think we're going to get into the curvature of space-time here, and that's...
So again, this has nothing to do with the curvature of space-time. It has to do with expanding space. So you didn't even get that argument right. He obviously watched this video previous. Come on, there's no way he's watching this cold. So he knows what their silly argument is. Their silly argument is that space is being poofed, and that's how it's losing its energy because it's parallel to a photon being stretched. And somehow the matter's energy is being stretched out of existence.
That's why general relativity principles say it's not conserved. But
So they don't. Okay, I don't think Einstein ever said energy isn't conserved. So I think that's just all bullshit. Sorry, no sale.
for all intents and purposes, like operating your nuclear power plant, it's a pretty key energy balance that we look at for a sustained chain reaction.
So again, the sustained chain reaction is where you're breaking atoms into bits, in the sense that you're releasing what was the strong force. That is, you created a nucleus where you put an electron, a proton, and an electron, and a proton in proximity to each other, and the two protons essentially can't see each other through the electron, so therefore you can get them very close. But if I kick that electron out, obviously I have two protons that are insanely close to each other, and their repulsive force will kick in, and they will see each other and run the fuck away from each other at a very high velocity. So that's the energy you're taking advantage of. All right, that's what you're releasing. And the fact is, all you can do is exchange it. All you can do is give it to something else, hit it, that thing hits something else, then that thing hits something else, and then that thing hits something else, and then that thing hits something else. You can just get the release of the stored energy that's going back and forth, or going in a circle. So you can trap energy in a circle, you can trap energy going back and forth. And if you release it, well, now it keeps going everywhere. It just keeps going to all kinds of, it has new adventures, Pee-wee's Big Adventure. It has a new adventure every day.
So, unless you're dealing with really long stretches of time and really big areas of space, then yeah, it's not conserved, but
Yes, it's not conserved, but it is conserved, but it isn't really conserved, but it's sort of conserved on the conserving part, but the erv and the con aren't really the same thing. You know, there's conning and then there's serving, and the whole thing's a frickin' con. This bullshit conversation about somehow they are demonstrating or have proven or have one shred of evidence that Descartes was incorrect when he 350 years ago did better physics than you morons can do, and figured out that, oh yeah, the energy just keeps going. I can just follow it. If I could tie a string to it, okay, I could give it a bag of popcorn and it could leave little trails behind, then the energy would show me that it's constantly going somewhere and doing something. Oh, you people are just pathetic. And these commercials are pathetic. God, I hate this planet. All right, continuing. He says, but eventually...
throughout, I don't know, from the perspective of the
Another jump cut. I don't know. Jump cut.
astronaut, yeah, it might as well keep going on at a constant speed forever.
Okay, so from the perspective of the astronaut, might as well go at a constant speed forever. So you shouldn't have bothered with the forever part. You should have just said, well, during the astronaut's lifetime, it will only lose 0.0003% of its momentum, its velocity. You could say something reasonable, but no, you didn't. You could say something scientifically correct and accurate, but no, we don't bother with that, do we?
20th century, the problem of energy conservation baffled some of the greatest minds.
So this is just bullshit. There was this whole baffling about conservation of energy when you can see it everywhere. Every single case, you can never make energy disappear. I mean, he runs a nuclear plant. They know, well, where's the energy go? Oh, that's right. We put it into the walls, and then we pull the energy out of the hot water. We create steam. We make the turbine spin. Then we turn it into electricity. It goes through a wire, and it makes another motor spin. I mean, come on. Where we know that, we know exactly how much we're going to lose to the atmosphere and the transmission lines. We know where all of it's going. We can trace it all. So why are they proposing this nonsense that somehow energy dies somewhere? It can't die. It has to be taken. And then something that took it has it.
Including Albert Einstein. Einstein came up with a possible solution. But then, a little known
So Einstein's field equations are contrived merely to the only reason why they exist is because he was challenged by Eddington to have an answer for why mercury processes erratically or inconsistent with just plain Newtonian mechanics. Why it processes. Where's it getting this extra tug from? All right. Now the simple answer is because the center of the sun is not staying in the same place, that the sun wobbles a little tiny bit, and it's enough to wobble mercury because it's insanely close to the sun, but it doesn't wobble anything else because everything else is so damn far from the sun. So there's a simple answer, but they don't like simple answers, so they come up with this crap. But anyway, so Einstein was challenged to come up with some math. He came up with math that is so convoluted, so abstract, so preposterously difficult to do that I have never seen a video where somebody actually calculates the procession of mercury and actually gives you a number. Never happens.
unpaid mathematician named Emmy Noether proved he
It's all this bullshit, I mean, I'm all for pro-woman, blah, blah, blah. But here are two key points in physics. Madame Chartelet, okay, a silly slut, okay, who, was plainly accused of plagiarism, and this Noether bullshit, as if this was some critical introduction into physics, some notion that something symmetry has something to do with conservation. Yeah, that's right. If something's equal, if there's an equal sign, it's probably conservational. I mean, this is not brilliant physics.
was wrong. And in doing so, she created a whole new paradigm for physics.
Oh, look, yeah, sure, yeah, I know all about that Noether theory thingy. Sure. Fuck you. Too silly. Look at the picture they're doing. Look at this preposterous nonsense picture. This is not physics. Physics is electrons and protons being pushed around by a very consistent force. And all of this horse shit is just that shit. It's bullshit.
One that underlies all of particle physics and...
Right, and so show me that for a tiny second and then talk about symmetry. This silly diagram of these muon, puon, zuon, duon, Higgs boson. I mean, it's all bullshit. Where's the symmetry in any of that crap?
explains why anything is conserved.
So again, they want to believe in poofing force and poofing matter. And that's all this is poofy fucking physics.
I do remember briefly touching on conservation of mass in high school physics, though.
Conservation of, again, how do you destroy, where? How can you destroy mass? And so he's a nuclear physicist and he doesn't realize that I'm not destroying the mass, I'm transferring it, I'm moving it somewhere else. The exploding atom, okay, essentially, the fractured atom, all right, is expelling its matter. That's what the radiation is. Little pieces of expelled matter. Beta, alpha. Shit. Just amazing. I'm just trying to think if they think gamma is neutrons, but that would be, that would be a mistake. Anyway, leave us continue.
Debunking that one takes about 5 seconds, and that is my nuclear reactor.
So he just says he debunked conservation of matter in the universe. So he's a nuclear physicist, and he actually thinks that electrons and protons that were in the atom are destroyed by the process of decay. So when the atom decays, it destroys protons and electrons. Bullshit.
Works, because there you're relying entirely on your mass defect to produce energy.
So there's no mass defect, okay? So again, you've fractured something that was held, a bunch of magnets are held together in a pattern. You've injected some kind of disruption, and now the magnets aren't lined up anymore and they fly apart. I mean, there's videos of that. So we know how it works. It's a balanced system, and the system is vulnerable to becoming imbalanced. And if you imbalance, it fractures. This is not nuclear physics, right? I mean, it's not brain surgery, and you're failing dismally, frankly. If this is what nuclear engineers are doing, then I'm not surprised that there's a Fukushima, that they couldn't figure out how to put the batteries in right.
The change in MC squared. Could also just...
So the change in MC squared. So we know that there is no MC squared that can do anything called work. And we know that it can't be exchanged, especially in the space example where the big atom man throws one of his little electrons, some of his matter away, and it flies away with some kinetic energy, but he doesn't get his share. There's no conservation. Oh, you people are just so pathetic. This is so bad. This physics is so rotten and stupid and ignorant and unthoughtful and uncareful and all of those things. It shouldn't be debunkable by a character like me. I shouldn't be able to see right through this shit they talk. They can't. They're not even clever lies they're telling you. These aren't even clever lies, and you're falling for it. God, bad on you. Bad on them for lying to you and pretending they thought about it for 10 minutes. Bad on them for lying that they're experts at anything. Okay, but real bad on you for falling for it.
Say the sun work, because there is a mass defect associated with...
So again, a mass defect. There's no mass defect. The little electrons and protons are still in the universe. They're just not in the sun anymore. Now they're expelled and flying towards the Earth, and then get deflected by our magnetic field, and then end up going somewhere else because of that deflection. But they don't die. They don't disappear. They are not unconserved.
Nuclear fusion as well.
It all started in 1915 at the University of Göttingen, where Einstein was giving 6 lectures on his new theory of gravity, what would become the general theory of relativity.
So this was 10 years after his initial papers. So he had time to fix, and try to contrive up something that he could try to make sense out of. But it's still garbage physics. It's just woo.
The lectures were well received, but Einstein hadn't yet settled on the final form of the field equations.
Right, see, so he's had all this time to fix them, and he still can't get it right. So let's understand, 2 years before the Eddington experiment, Einstein didn't think light was bent twice as much by gravity. So the very thing the Eddington experiment was out to prove, if they would have done the experiment previous, to Einstein's revision, which was they tried to, but World War I got in the way. So in 1917, they tried and the war was in the way, couldn't do it. If they would have done the eclipse experiment then, their results, if they found that light is twice as bent, then it would have proven Einstein wrong. So that's the irony of this whole thing. It's just so ridiculous. It's that ridiculous. I mean, of course, they've never repeated the goddamn experiment, and of course, they've never tried it from space, which is the most logical thing anybody who believes in science and physics would suggest is, why don't you do the experiment from space where there's 400 fucking times higher resolution, 400 times better seeing, and you don't even bother trying the experiment? Fuck these people.
One problem he was facing was how to show that...
So now he's showing this gravitational wave crapola that Einstein didn't believe you'd see, didn't believe was a strong effect, all of that crap. And again, they blame that on Einstein. Einstein said you never see an Einstein ring. It'd be impossible to see one because it's only a tiny sliver of photons. There would never be enough light for you to see an Einstein ring. And yet these assholes call them Einstein rings. Amazing.
Total energy was conserved in his new theory.
rather charming commercial. Well, I could use a break. All right, I'm back. Did you miss me? Anyway, so now she's saying this is the beginning. So, of course, they have a woman commenting on the brilliant woman. Bullshit, bullshit, bullshit. Jesus Christ, such obvious bullshit. But anyway, let's play along. Again, I think women are just as capable. It's just that they get fucked with a bunch of nonsense as a kid. They get told they're supposed to be a woman, and an asshole, and an idiot, and a bitch. They're trained. They're given bitch training, slut training, all kinds of training that turns them into fucking imbeciles.
Of this story, right? Classically, they thought they had this understanding of what the energy of a gravitational field was.
Just kidding.
So this energy of a gravitational field, again, they think it's a piece of bent space. It doesn't have any goddamn fucking energy. How can it possibly have energy? Where did the energy come from? So again, the very existence of this physical mechanism that's causing matter to move, and there's no source of it. Because they're not saying it's a pressurized universe, and that's why things are pushed together, is because, frankly, the universe is pressurized, okay? There's a bunch of force pushing you into the earth. You're not being pulled by anything. The very fact that they can't even figure out it has to be a fucking push-averse. There's no such thing as a pull. It doesn't exist as a concept. It's implausibly nonsensical. You can understand push. It's this simple. There, I've created a demonstration, an analogy, push. Okay, there's no pull. Please. No, there's no such thing. They can't even figure that out. These people who pretend to be smart. And they're really, 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 really dumb.
A lot more subject matter experts on his channel. I like seeing that.
Oh yeah, subject experts on this channel, right? So they go to the experts. It gets dumber and dumber and dumber. The more little credentials they have, the more little badges they have, the more they've been rewarded for being woo-assist and being great propagandists for the bullshit. Okay, you don't get an award for talking the truth as a physicist. You get an award for being exceptionally good at fooling people with absolute babbly nonsense and convoluted, insanely silly equations. Oh, it's disgusting.
All of a sudden, with these new equations, they go, where is it? Is it in the curvature? Is it in the stress?
So the point is, they're doing an orbit. The point is there's this insane amount of energy, right? They say, it's this incredibly weak force. It's moving fucking planets, for fuck's sake. It's an insane amount of energy required to move planets. All right, and they say it came from nothing. The velocity, we say, that came from impacts, meteors, all kinds of things gave the Earth its orbital velocity. But somehow, its velocity towards the sun, it's just magical. Magical energy causing a magical event. And the only way they make it conservative is the fact that anything that interacts in gravity is going to gain as much as it's going to lose leaving. So that's the only conservational part, is something that goes into a gravitational system will gain what it has to give back, leaving. So that's the only part that's conservational. But its existence is not conservational. The fact that it's anti-entropy is not conservational, in the sense that you can't deny the fact that it's exactly negative entropy. It's creating unentropy.
Energy tensor. Where's the term that we're looking for?
Yeah, where'd it come from? So we have an event. Poof. There's no cause for the effect. The effect is gravity. They have no physics explanation for why the matter moves. There's no bowling ball that caused it. There's no splitting atom that caused it. There's no mechanism where you say the energy was stored. There's nothing. There's zero explanation. It's vacuous nonsense. It's spooky fucking action at any distance. I mean, Einstein is guilty. He's such a hypocrite, a duplicitous hypocrite, to complain about spooky action when that's all his theory is spooky fucking action.
Einstein suggested that the principle of conservation of energy, long established as a bedrock of physics, might hold the key to working out the correct field equation.
So that's a big pile of convoluted nonsense. It certainly isn't implying that Einstein said there was no conservation of energy. Yes, I don't see Einstein. He didn't quote Einstein as saying that. So he used a bunch of jargon to suggest, well, Einstein thought this was an important subject, but he certainly wasn't on the side of people who said there's no conservation of energy and energy just poofs into the universe.
In the audience, legendary mathematician David Hilbert was intrigued.
So this is where they create the Hilbert space. So they have all of these redos of the original thing, and then they create all these new concepts that are all distortions and perversions. So it goes back to the fact that the people who they say invented something don't even believe what they're arguing. So again, I could quote Einstein on gravitational waves. I could quote Einstein on Einstein rings. They're not their beliefs aren't Einstein's belief. Einstein didn't believe that when something merged in space, it converted matter into energy. That's not Einstein's theory. That's that crackpot movie script writer. It's not physics. It's made up shit.
So he started to look for the energy conservation equations in Einstein's new theory. But the best he could find was a set of equations known as the Bianchi identity.
So the Hilbert space is found the Bianchi irregularity, and it just goes on and on. This horse shit. This is like their particles. The 400 fields and the 400 different little Higgs boson. They'll find little baby bosons, and then they'll find rhinoceros bosons. It's just such a pile of shit.
They showed that energy was conserved, but only in a completely empty universe. So for one like ours, filled with stuff?
Yes, so all you need to do is interact with matter, okay? You can't just interact with a force. So we know the force doesn't stop something from moving. So when something's plowing through the universe and it's plowing through the pressure, somehow the helium nucleus, that's the basic core of all atoms, that is capable of maintaining its velocity if it just has to deal with force. But if it interacts with other matter, then it has to make the exchange. Then it loses its velocity. Those are the simple rules.
Stuff.
They seemed useless. Hilbert was stumped.
Fortunately, he knew just the person for the job.
Oh, this guy, I don't know who this guy is. I don't know why I have to listen to this guy. I don't know why he's in these videos. Just annoys the fuck out of me. Sorry. Annoying twat is going to tell me what reality is. Casper, the friendly Norwegian. Oh, fuck.
Job. His new assistant, Emmy Nutter.
So he says nutter, and he's going to say another. So every time he says another, it sounds like nutter again. It's just hilarious. No, this is a petty thing to bring up, but I'm just saying. Fuck.
At an early age, Nutter had dreamed of following in the footsteps of her father, a mathematician.
All this bullshit, blah, 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 blah. Hero. Yeah, and then we all find out that the heroes are full of flaws and child molesting and who knows what.
Professor at the University of Erlangen. She got special permission to attend lectures at the university, but they refused to admit her.
Yes. It was a bad world where they kept women from going to college. But now women are going to college, and guess what? They're just, wasting their time because they get a job that doesn't have anything to do with their degree in so many cases. So they're just wasting this chair. There's no point in sitting in the goddamn chair to be a physicist if you're not going to be a physicist. You're just taking up a chair that you should give to somebody who really wants to be a physicist.
As an official student, the Erlangen Academic Senate held that the admission of women would overthrow all academic order. So, in 1903, she spent a semester at Göttingen instead. There, she learned about a new way to approach geometry, using symmetry.
So this is just unmiraculous, frankly. I mean, frankly, it's just unremarkable. We all know fractals. We all this stuff is, you can see it all over the place in the world where, um, you know, triangles become squares. It's just, and the funny thing is that geometry has everything to do with the structure of a nucleus, and they've never even properly attempted to diagram that geometry, because that's really all it is about, is arranging electrons and protons. They just clump them into a blob and say, look, there's the nucleus. It's this blob, little roundy thing. It's not a little roundy thing. It has a hard geometry.
Symmetry is one of those ideas that's easy to recognize, but harder to describe.
If I align a mirror on this triangle like so, then it looks the same as without the mirror.
Sure.
Who cares? It's just these. So we go from Hilbert space and Bianchi exclusions to, look, a mirror reflects things.
And that's because this is an axis of symmetry. Reflections about this axis leave the triangle unchanged. And the same thing happens if I put the mirror like this.
Yeah, no, it would have been more interesting if they would have just put the mirror on a human face and pointed out that there's a lack of symmetry. So even though it looks symmetrical, it's actually not symmetrical. The two faces you'll see, the two faces created won't be the same.
Or if I orient the mirror like this. So this triangle has 3 axes of symmetry.
Symmetry is another important thing when designing nuclear reactors. So ideally,
this ought to be interesting, how he's going to contrive some way to bring symmetry into a nuclear reactor. I mean, what a pile of crap.
you'd like to make the reactor vessel a sphere, so you have a uniform power profile. However, that's really hard to do, so sticking with the cylindrical design where you still have a fair bit of symmetry but not in every direction is the most practical.
Okay, so he's just conceding that this is just, don't want hot spots. So obviously a circle from a nucleus would give you the same temperature all the way around. And any time you have to deviate from that circumstance, it's going to cost you in terms of hot spots.
Now, mathematicians generalize the idea of symmetry further to be any action you can take that leaves an object unchanged. So something else I could do is I could
leave an object unchanged. So there's nothing you can do in terms of the physics that's really outside of the principles involved in those Newtonian concepts of interaction, and you're going to conserve the momentum. That's always going to be true.
rotate this triangle.
Okay, I think I get what they're going at. They're talking about that if you have symmetry, then you have energy conservation. But if not, that kind of throws it out the window.
So it really doesn't. So it's really, what's the point of this argument? Because even if the whole universe wasn't symmetrical and it had an imbalance in one direction, it'd still be conservational in the sense that that direction can't be changed or altered unless some other counter force, equal opposite, has to happen. So there's no way the universe can lack symmetry. That would mean that there has to be more poofing over there than there is over there. There's no poofing at all. So there can't be a lack of theoretical symmetry in the sense that you could separate all the white ink from all the black ink, all the electrons from the protons, and you'd end up with the same charge on one side as you had on the other side. It all is conserved. Oh, shit, now what's wrong? Play.
And considering there's no universal standard time, or no real universal standard time, that
So again, that's another one of their bullshit wooey concepts, that somehow time isn't regular in the universe. That it's not the same time here as it is on the moon, and then it is on Pluto, and then it is on Alpha Centauri. That right now isn't a time, and they're all going to pass time at exactly the same rate. That is, isotopes. If we have to use the decay of isotopes, they're decaying at the same rate. If there was a frog in a jar, he's going to age at the same rate in all those places. And it's just a lie to say that something else is going to happen, because nothing else is going to happen. Because the same clock is ticking for everything, and that clock is the speed of light. the speed of interaction. The fastest interaction that can take place happens at a specific speed, and that's time. And they're breaking that commonsensical concept to preserve a notion that we know isn't true, that somehow you can jump to some other time. You can't jump there. If you want to see the future, you have to be frozen. You have to stop your metabolism from metabolizing. You have to stop your eyes from blinking. You have to stop all the regular things tied to time passage, and you have to stop all of those processes from processing. And frankly, it's not going to happen, but that's the only way to do it. You have to freeze yourself and wait for the future to get here. Fact.
Kind of throws it out.
By 120
But a lot of
degrees,
times it's still
or by
close enough.
240 degrees, or by 360 degrees. Together, these 6 actions capture all the
Hey Meta, is energy conservation
Oh, fuck. So this is a commercial. Hey Meta, is energy conservation key in thermodynamics? Well, let's listen to the commercial.
key in thermodynamics?
That's correct. It maintains efficiency and balance in systems.
Oh, geez, baby talk.
Got it. Now, teach me how to tie a Windsor knot.
Cross
Oh, brother. All right, now we'll get rid of the commercial. All right, some blah blah symmetries of the blah blah.
equilateral triangle.
But you can also have more abstract symmetries. For example, with a mathematical
Sure.
function. If I shift this function up or down by some constant amount, call it a, then all
All right, so this is just sort of abstracting the idea that this is really just down and up, all right, and that I can change the size of the down and up and the proportions, and I can make a little tiny one, I can make a very big one, I can make lots of things that would make them the same after I've processed them. That is, I could zoom the camera into the little one, I could zoom the camera out from the big one and end up with the same identical pattern. So what? Not not even close to interesting.
of its y values will change. But if I differentiate that function, I get the slope, and that remains unchanged regardless of whatever constant is added. So you can add any constant to this function, and its derivative
Is
always
zero.
stays the same.
Yeah, constants go away when you take the derivative. Man, I wish I had this guy in calculus class.
Oh, brother. So again, it's not miraculous to recognize that it's it's that simple. I mean, obviously it's just changing where the 0 point is in this case, so that's really obvious. But I mean, are we all too stupid to figure out that if I have an electronic circuit and I have 5 volts and 0 volts, that I could do 4 volts and minus 1 volt, or I could do 3 volts and minus 2 volts, and it would all be the same? Oh yeah, no, I don't think we're going to fall for that. That's a reach. Oh shit.
For me, calculus was always one of those things that once I got it. It just took me a little while.
So there's a kind of
I just like to see somebody actually do calculus, that is, do the integrals, because they never do them. I mean, let me see the whole process, and let me see if I could draw it and get the answer faster by just drawing it on a graph. I'd like to see the competition between somebody calculating the integrals and somebody drawing it on a graph and then cutting the pieces of paper out, okay, and figuring out how much space, how much area was under the line and all that kind of crap. I mean, there's so many ways you could do the experiment with beans or any, grains of rice, and maybe I could just calculate the grains of rice quicker than you could do your integrals.
translation symmetry. And unlike the symmetries of the triangle, this is a continuous symmetry, meaning you can shift it by any
Yeah, it's still a
amount you
continuous
like.
function.
All right, but again, it's not saying anything.
Yeah.
Over the next 12 years, notice
I mean, up and down. That's all it was. It's just an illustration. Yes, you went up and then you went down. And you did it all symmetrically, so it makes it very easy. So as soon as I put a kink in that line, you're all done with your simplicity. Your simplification won't work anymore in anything real.
became a leading expert on symmetry. She became only the second woman in Germany to earn a PhD in mathematics, and she
Blazing the
used
trail.
this expertise to help Hilbert
You can't talk while somebody else is talking. Just saying. Nuclear physicist guy. no point in saying shit while he's talking because I can't tell what the fuck you said.
And Einstein with their problem of energy conservation. The issue had bothered Einstein so much that he proposed a new conservation equation. It said that if we add together the energy of matter and the
All right, so this energy of matter thing is just another contrivance. There is no energy of matter. If I could actually get an electron to stay in one place, it doesn't have any innate energy. What it does have is it takes up space. And by taking up space, it means the force that actually is in the universe is compressed more because you've taken away some of the space it could travel in. Therefore, it has more interactions with each other. So the more space I deny a bunch of little BBs in a box, and if I start taking away their space, their energy goes up because they're transferring more often. Because they have less space to travel in. If I make an aperture smaller and smaller and smaller, the likelihood that the photon has to go right next to a surface goes up and up and up. So I create more fringes. I mean, this is not hard science. I mean, this isn't, you people shouldn't be fooled by this crap.
energy of the gravitational field, then that total remains constant.
So there's no energy of the matter, okay? And this fake notion that the field is just some sort of bent geodesic that just duplicates the inverse square law. So it's really just, his bent geodesic is just a fake notion of the inverse square law that you actually do have. Like look, Leonard Susskind, the Stanford's leading expert on Einstein gravity, how does he teach it? He teaches it by describing it as water pressure pushing objects at the inverse square law. I mean, he might as well just do it by pointing at a light bulb and say gravity is exactly what those photons are doing. It's just the direction is reversed. So exactly what the photons are doing, that's exactly what gravity's doing. It's just doing it in the opposite direction. There, we're all done teaching gravity. Einstein's gravity. Because all it is the inverse square law, which obviously is Newton's gravity.
Its change over time and space is zero. But when Noether
He says,
saw this, she was convinced Einstein had made a fundamental mistake, because this equation disregards the foundational principle that general relativity is built on.
Yeah, so Einstein violated his own principle. Jeez. It is hilarious.
10 years earlier, in 1905,
Yeah, you can't globally divine a
So again, he is acknowledging what I said was true 10 years earlier. So this is before the lecture where Einstein's trying to make all this stuff fit together, and it's still a pretty ugly fit.
conserved energy. I guess it's another way of looking at it would be energy wouldn't be conserved in your reactor room if your reactor room was big enough that the reactor's fuel, coolant, radiation it emits, and its structural mass curves the room, and when that starts...
Okay, so this is more bullshit. This has something to do with space curvature. It has nothing. Conservation doesn't have anything to do with space curvature. It has to do with the origin of space curvature. And the argument is that gravity, the consequence of gravity is the bent space. So you're still stuck with the idea that you have to create this source of motion. The motion doesn't have there's a cause without the earlier effect. The bending happens without any energy creating the motion. There's no piece of energy being used to make something move. That's the flaw in gravity. This curvature argument doesn't have anything to do with conservation and any other notion. It only applies to gravity. You can't apply it to a nuclear power plant. The nuclear power plant is spewing bits of matter with momentum, and it only had so much of that trapped in its nucleus, and that's all it can give away. It's what's trapped in the relationship between the electrons and the protons. The charge is what you're doing. You're releasing the charge forces of proximity.
to get significant. It would take a lot, though.
So, No, it's not even theoretically a subject. You're not going to bend space by splitting atoms. Not going to happen.
But ultimately, it's close enough for talking about your heat profile in your reactor.
So the heat profile is perfectly conservative. This is all bullshit. There's no, they don't they don't lose any element of it somewhere. There's no, they're counting every neutron theoretically. In terms of there's always, well, yeah, there's 3,468 neutrons. They know how many it is.
Einstein had introduced his special theory of relativity, and it was built on the idea that the laws of physics were independent of your frame of reference.
All right, so this is true, but not the way they're saying it, okay? The speed of light is constant everywhere, but it doesn't mean that if I'm going the same direction that photons are going, that somehow the photons keep going faster, at the speed of light away from me. So I'm going the same direction that a laser beam is going. And I start going faster and faster. Well, the laser beam's not going to go any faster. They're not going to leave me at the same speed. I'm obviously going to be able to almost see the photons because I'm going to catch up to the photons in terms of they're not going to be zooming past me so fast that I can't see them anymore. That kind of thing. It's just a fact. There's no rule that I cannot perceive light or something else relative to my speed, because that's what it will be. Now, if something reflects off me, I'm moving forward and it reflects off me, it can only reflect off me based on the forces that are manipulating my electrons and protons. And so they can't produce a photon going faster than the speed of light. They can only reflect the energy based on their motion. And obviously, if I'm moving in the forward direction and my electrons are being pushed by a force, they're going to reflect at a different speed. So there's no theory here that says, it's just this simple argument. If I move my hand at the speed of light and the light can't reflect off my hand any faster, then yeah, it's stuck. I've collected it essentially. And if I reverse my hand, if I make my hand go really fast that way, no light will hit it. Because no light can catch up to it. So nothing will reflect off of it, and it'll be invisible. Fact. This whole Einstein thing is just such crap.
But so far, Einstein had only applied this principle to inertial frames of reference. Those are frames that move at a constant speed.
So he'd only done it in the context of accelerations. In gravity, essentially. And the general theory was for accelerations happening in all circumstances. But obviously, then we get into the whole conundrum of kinetic energy that makes a mess out of all of this.
Began wondering what would it take to generalize that, to consider more general states of motion. After all, trains on the platform. He loved trains. Trains would speed up or slow down. People.
So we have no evidence that any theory of Einstein's applies to a train. Okay, so again, this only has to do with when you're going insanely fast speeds near the speed of light, because that's where he's creating this pretense that all of a sudden time has to be broken because you have to see the photon bounce off of you at the speed of light. Even though it didn't, and it won't, you have to see it that way. And there is no truth to the subject, and there is no equivalence. Me being pushed by rocket engines, just because a human being will sense that it feels the same gravity, the same motion, doesn't mean it's the same mechanism, because it's not. Gravity is this minute force that travels through every bit of you and moves every atom equally. Well, forces that are pushing you aren't going to be doing that. The bottom of an elevator doesn't do that. The cause of your motion is what needs to be understood, and most of the motions that we're affected by are material motions. They cause us to move. Matter moves, hits us, makes us move. We're not moved by forces except for gravity.
Moving around the world don't only move at a single constant speed forever.
In 1907, he wrote, "Is it conceivable that the principle of relativity also applies to systems that are accelerated relative to each other?" This made him wonder.
So it doesn't even make any sense. Of course, there's a thing called relative motion, but it doesn't mean that there's no absolutes in the universe. So we're all the way back to Newton's bucket example, and they still haven't debunked it. So Newton started his presentation about important physics, and what was his first argument? His first argument is that space and the three dimensions are absolute. He wanted to debunk Einstein before Einstein even existed, because he was debunking people that were already talking this kind of relativistic wooey. And he was basically saying, look, relativity is just a circumstance where it looks okay, but the fact is obviously if I'm tied to my hand, so me and my hand are moving relatively the same, all right, but there's nothing surprising in that, and then my hand can have a new bit of energy imposed on it, and it can go in a new direction. So I could be made out of a bunch of pieces, and a bowling ball could hit and knock some of the pins in a direction, and now I don't have the same consistent relative motions. Now our motions are different, but it's absolute, and everything's spinning. So Newton made a lot of arguments about spinning things. You spin two balls on sticks and you can make them go further out. Okay, the whole universe isn't spinning. The only rational conclusion is that motion of those two balls is being created because they possess energy. They have to have it. There's no other explanation that's viable or sensible, because even if I spun the whole universe, it wouldn't make the whole universe have more gravity. It wouldn't make the whole universe capable of moving the ball towards the whole universe. So they have never defeated that argument, and yet they talk this wooey shit.
Perhaps his principle could also be applied to accelerating and rotating frames that move in any way in general.
Right, so Newton already debunked that argument, okay, 350 years ago in his first physics argument. He debunked this notion that you need to bother thinking about how the universe is constructed. It's three-dimensional space, all right, and there's stuff in locations in the space, and that's it. Space is just a location. It's empty except for the property that it gives something a location, and it takes time for things to get to other locations, and time in this case ends up just being energy. You need energy to move distance in the empty space. And there's no other mechanism. There's no bent time, there's no bent space, there's no corrupted matter, and there's just force equaling momentum. Another Newton direct statement. F equals mv. That's what he really wrote.
That's the general in general relativity.
Yeah.
So Einstein
Yep, that's really it. Yep.
got to work on this.
He's a yep man. All right, well, I guess it's an hour, so we'll call that a part one. I don't know if I'll bother with the part two. I guess I should get to the point where he makes the argument that somehow it's the expanding space that is destroying the energy of the meteorite or the rock. That somehow its frequency is being lengthened so large that it lost all of its energy because its frequency got big. Some kind of crap like that. All right. Just terrible. All right, so if you haven't heard me say it before, I hate this planet. Just hate it. Covered in idiot. Anyway, till the next time and such. Doopy, stupid, wooey. It's a girly planet. Fuck.